Hello and welcome, everyone. Today, we're excited to be talking to you about one of the hottest trends right now, AI agents, and how they have the potential of reshaping our world. It's happening as we speak. My name is Theo, and I'm a technical director here at Mindit. I'm passionate about all things data and AI, and I have experience in various industries from retail to gaming. Um, I've been writing software for about a decade now. And before that, I was a business user, decision maker, product manager. And I was spending a lot of time doing lots of manual stuff, data crunching and a lot of other things. And with little support from IT. So over time, I have transitioned to software and AI, and I see now the potential it has to make our lives easier. And here we have my colleague Dumi.
Hello, my name is Dumitru Pascu. I am a software engineer with over 20 years of experience in various industries like telco, retail, or healthcare. And I currently have the role of CTO at Mindit.io. I'm always keen on improving software development lifecycle, and I am passionate about software engineering in general, and more recently, passionate about AI engineering, which in the end is just a form of software engineering that integrates AI in software lifecycle. So let's start.
Yeah, let's have a look
Uh,
at the agenda.
yeah, let's look at the agenda. And as you can see, nowadays the human language becomes the digital language. And here's one famous tweet back in 2023 suggesting this idea that the hottest new programming language is English. So with that in mind, stay tuned for the topics that we will cover in this webinar. The first topic is current state of AI agents, where we will define AI agents. We will discuss the existing roles and application of AI agents in various industries, and we will highlight recent developments and significant impacts. Following that, we will focus on the future implication, and we will explore how AI agents are expected to change in the future, and discuss a little bit about the potential challenges and ethical consideration. And in the end, we have two demos. One live demo of a sample AI agent in action, and one AI agent that may spark your imagination for future use cases in the near future. And also, please stay tuned towards the Q&A session because we have a surprise for you. Three AI agent POCs with standard tools for selected members of the audience. But for that, you have to stay and to complete our final feedback form. So, Theo, let us start talking about the current state of AI agents and perhaps a little bit of history to understand how we reached this point.
Sure thing, Dumi. Let's start. And before we define exactly what AI agents are, I want to give you a bit of history. Let's walk together down memory lane for a bit, and let's have a look at how ChatGPT. We all remember how it took the world by storm when it appeared, and it was, crazy good. We had all sorts of interesting conversations with it, but it was in essence just a chatbot, right? You would just go back and forth, writing text and receiving text as output. So you would have a conversation, but it's useful. I'm not saying a conversation is not useful, but that was it. Then we also had the problem of these chatbots not having access to recent data about recent events, right? So they have what's called a knowledge cutoff date, which is when they were trained, and they know up until that point the facts, but what happened yesterday or what happened today they don't. or what happens inside your company in your using your proprietary information within your enterprise, they don't know about that, right? That's your secret, that's your trade knowledge. So that's why when RAG came to the scene, retrieval augmented generation, it made chatbots more useful because they could now access data from within your organization and anchor responses with facts that are useful for you. But also they can anchor their responses with information about recent events. Now take a step further and we take a look at copilots. Remember GitHub Copilot, more recently Microsoft Copilot, and other copilots which maybe are not named Copilot, but in essence they're the same thing. They're AI agents that work side by side with a user to complete a task. For instance, Copilot, when writing code, it's essentially you're instructing the AI to give you a piece of code to do something, and it will prompt you with that piece of code, but it's still up to you to accept that piece of code that it writes, or you have to make changes yourself and then apply it, right? It's not doing things by itself. But then the next in line is fully autonomous agents. These are agents that can respond to stimuli with minimum human intervention. These are things that you can, instruct, and then they take care of things and they come back when they have a result. So imagine from moving from asking AI for recommendations about going to a restaurant to actually taking action and not only recommending a restaurant, but also booking one, maybe ordering a taxi for you. So how cool is that? So this is what I just wanted to go a bit on memory lane, but
Yeah, so Theo, I guess that the industry is close to reaching workable, fully autonomous agents soon. Not sure we are exactly there yet. And
mhm,
so let's dive a bit deeper into the basic building blocks of AI agent as we understand them
yeah.
today, shall we?
Exactly. Bloomberg declared 2024 the year of AI agents, but I think that 2025 will be the year of usable AI agents. Um, we'll start seeing benefits soon. So, but first, let's zoom in a bit. What is an AI agent? What are the basic building blocks of an AI agent? So, at its core, it's a large language model, the one that similar to the ones that we have been interacting with, like the GPT-4 or 4.0 or 3.5 before it, and at its core, it's a large language model, but it now has access to uh, retrieval, which makes it access your proprietary knowledge or recent events. It has access to tools. What I mean by tools is interacting with any external system. It can query APIs, submit or run code even, right? It can actually, its decisions can actually have now side effects. They can lead to something, but also memory. They can also have short-term or long-term memory, which helps them in their decision-making process. And of course, we have on the left-hand side the input from the user or from other agents, as we will see in multi-agent architectures. And also at the right-hand side, the output, basically the output to the user, hey, I've completed the task that you gave me, or an output for another agent in multi-agent systems, as you will see. So these are the basic building blocks of an agentic system.
So basically, an agent has a large language model at the core with access to tools, data stores, and memory to make reasoning and get finally an output.
Mhm.
And but more specifically, let's see what are the typical patterns for working with agents. And
Mhm. Yeah,
let's
yeah.
present this
Let's
React one.
let's have a look. So having in mind what you just saw, let's imagine how an agent can actually be useful and not just a chatbot when we give it a task, when we set a goal. And this is the React pattern here, which has basically a reasoning step and then an acting step. So first, it thinks about the goal that you've set out for it. It then takes an action to achieve that goal, it interacts with the environment in a certain way. So it could query an API, it could get data from an external data source or whatever. It gets from the environment the needed information or the output, and then it does an observation. And then it reasons about, hey, is this enough? Can I stop? Have I completed the goal that's set out for me, or should I continue? And then if it doesn't reach that goal, it runs in a loop. It thinks again, what have I achieved so far? What do I need to do next? And it executes another action with the environment, possibly different, right? And then comes back with another observation and goes on until it reaches its intended goal. So does it sound like a human doing reasoning, right?
Yes, like a person that is
We
working iteratively, and
exactly.
yeah. But moreover, let's see the following example that you
Hmm.
have prepared for us, and
Yeah.
see how it
Yeah,
works.
let's have a look at an example. Think about it. Let's say you task the AI agent with something simple, like but seemingly complex. What is the population of France, and how has it changed over the last 10 years? So for it to have access, it needs to know the population of France today. It needs to know the historic population of France over the last 10 years. So let's see what it does, right? First step, it thinks, I need to retrieve the current population of France, right? Then second step, it takes an action. It interacts with its environment via the usable tools that it has at its disposal. Queries an API, gets the latest population data, and then it does an observation and thinks, okay, now I have the current population, 67 million as of current year. Now it thinks again, I need the historical data for the last 10 years. Then it does another action. The agent queries maybe another data source for historical population data. Then it goes on to another observation step where it sees that it retrieved the correct data, it has data for the 10 years, performs the comparison, and then in the final step, it outputs the answer to the user. It basically achieved its goal and it stops the loop, it exits. This is a
That's
simplistic example.
That's great, but this is just a pattern of work for a single agent. But
Hmm.
we know that the more specific the responsibilities, the better the agent output and agent behavior. So, how do agents communicate one to each other with different specializations so that they can achieve better results together for more complex tasks?
Correct, correct. That's a very good one because so far we've been discussing about one agent, right? And one agent can be still useful, can be very useful. As you've seen, it can reason, it can run in a loop, and it can run until it achieves a goal. But what happens um, when you need something more complex? Let me share you an analogy here, and think about when we used to work with computers in isolation before the internet, right? How useful were they? They were still useful. We would still use them, right? We'll write papers or use Excel or whatever. But then how useful they became when we connected them to the internet, when computers started working together, right? Everything exploded with the rise of the internet. So the same transformation is happening now with AI agents. So just as the internet transformed computing, multi-agent systems are now transforming AI, agentic AI, and generative AI, right? So there's still usefulness for isolated agents, but the power comes from specialized collaboration. So we have basically specialized agents that work together to achieve a more complex goal, right? And we can construct a lot more complex workflows, and we have a lot of orchestration patterns that we can use. And this is basically think of it as a team, right? You're creating a team, you're creating a job description for each member of your team, and you have basically each agent is an individual. It's a team member, right? You still have the need for managers, which these are the orchestrators. So another analogy is to think of it as basically a team of players working together. That's where the real power comes.
That's great, but what about a team that includes both AI agents and human agents? What about
That
that?
That's true. That's very true because um, seemingly when we look at the diagram earlier, you say, oh, but where's the human here, right? What we do, we just abandon ship and we let the robots run wild? No, humans will still be needed. Will still, AI is here to help us, not replace us. And there are two, let's say, sides of the coin that I would like you to look at. This is what's called the AI sandwich, or aka human in the loop. And usually there are patterns to interact with AI. You either have human at the beginning, then you give it a task, AI does its magic, it runs its analysis or whatever it needs to do, and then it comes back to the human and prompts it with results or asks question, hey, is it okay? Do I need to continue? So that's basically AI in the middle. It can also be the other way around. It can also start with AI, right? Think about it when you might want to create generate an outline or an idea for something to write about, right? You ask the AI to brainstorm and give you ideas. Then you do your magic, you write, and then at the end you give it to the AI to format it, to trim it, to make it beautiful. Okay? And it can all work both ways. So the AI can be either the filling or the bread. We still need humans. We still need people.
Okay, so
Okay. And
let's
now let's look at one example which uses both. It uses agents, but also human in the loop.
yeah, so have a look of a sample example of multi-agent orchestration. Let's take the example of customer service chatbot, and we will return during the demo with something very similar. But in this case, we have multiple agents. We start with the user agent, which can be a customer, which can be an employee that starts a task for the AI. Then we have a manager or a triage agent that is able to transfer towards the specialized agents, in this case, sales agents, issue and repair agents. These specialized agents respond to events, because here we have an event-driven architecture, and interact with the tools that they know, either the catalog of products for the sales, or either with the orders database, or the orders ERP in case of the issue and repair agents. But moreover, when the triage doesn't know where to route towards autonomous agents, it can escalate to human. But this is just one example. With this kind of architecture, we can solve so many problems nowadays. For instance, we have just received a few days ago a request from a customer that was asking us to develop an agent that monitors competitors offering, and issues a report on this, a task that usually takes quite a lot of time for a human being, and it's not always the most pleasant work to be done. Also used agents to perform AI enabled travel agents, so that we plan these kind of trips. All of these use cases were extremely very difficult, or if not impossible, to do in the past, to perform in the past. But now with the AI agents, everything is possible, and more will be possible in the future. Because Theo, let's have a look at the evolution in time and different type of agents that are already or may appear in the future.
Mm-hmm. Yep. And here's a table that we have compiled. It's not an exhaustive table. There are still other types of agents that we have not included for simplicity purposes. And there are others to come for sure. So we have many types of agents, like from simple reflex agents, right, that just operate based on a predefined condition, if else, which are simple and efficient, but cannot handle more complex environments and cannot learn from experience. We have model-based reflex agents which adapt and keep an internal state, and they essentially remember. They have this short-term memory that they can use. We have goal-based agents, and you saw earlier when we talked about the React agent. React agent is actually the React pattern is actually a combination, while not explicitly listed in the table. It's a hybrid type of agent and can be considered goal-based slash utility-based slash learning agent. Why? Because you set a goal for it. It uses utilities, tools that it has at its disposal, and also it learns, right? It reasons for each step and learns. So it improves over time, making it suitable for complex dynamic tasks. But also multi-agent systems that you see, the last one in this table. This is the systems of agents working together and competing in a shared environment, and working together to achieve a certain goal, right? Some agents may overlap in functionality. A learning agent can also be a goal-based or utility-based agent. So there's a mix. Yeah, let's have a look at also we saw all the pretty stuff, right? What agents can do and what's installed for us in the future. But let's have a look also at some of the challenges and ethical considerations that we need to keep in mind. And we think of this from a three-dimension perspective. And I want to point out the very first one, trust. And let me share you, let me share something interesting. When Bloomberg declared 2024 the year of AI agents, many focused on capabilities, what agents can do, and how fast can it do, and how cheap can it do. But industry leaders discovered something more fundamental. Trust is actually the real bottleneck to adoption. So consider a chatbot. We looked at the history earlier. When a chatbot makes a mistake in a conversation, it's annoying, right? Maybe it hallucinates, maybe it gives you false information. It's annoying, but it doesn't cost you a lot. When an AI agent makes a decision on your behalf, it could cost you millions, right? It could, let's say it's a self-driving vehicle. It could do something, cause you an accident. So we need to have trust. And trust is built by using validation, observability, and having control. Validation, we design AI agents to continually check in with people. Remember, human in the loop, right? To make sure they're on track, so that people can supervise them and oversee them. Think of this as a constant checkpoints. Observability, you need to see what's happening, not just the results at the end, but also the process, how it's thinking, how it's making the decisions, as you will see in Dumi's example a bit later. So letting agents run wild might work for a hobby project, but if you're building enterprise-grade software, you need observability and you need control. You need the ability to intervene, to adjust, to stop the process if needed, okay? There's also collaboration and there's strategy. I think we have time to go deeper into these.
Yeah,
but
we don't have time to go very, very deep because we really want to, we are excited about the demos as well. So yeah.
Yeah. And now let's say you're convinced, right? Let's say you have the trust and you want to get started exploring AI agents. Let's see how to do that in the next slide with Dumi's help.
Yeah, thank you. Here you can see a very, very nice, easy 10 minutes framework. The source of the article for this framework is in the slide. So it basically relates to four type of areas. So the first thing before you validate your AI project is to think about the pain level. So the question is, did you measure the friction and the costs for those frictions? Do you know how the solution looks like? And do you know the metrics for those solutions? So then this is a go. If you didn't even bother to measure the impact of your problem, then probably it's not the best project to start with. The second one is perfection. Is 100% perfection, accuracy, whatever in decision required, then that's a red flag as well because yeah, that's AI statistical learning. 100% accuracy is almost impossible to achieve. So this is something that you cannot, you should not take into consideration. So it is a red flag as well. Another red flag is whether your users will try to trick your system. On the opposite, if nobody is trying to defeat the system, and then in this case, for sure, this is a very good candidate for your project. And also, last but not least, best candidates for AI projects are human in the loop. And yeah, we are here to help you. Please check out our website and search for AI Innovation Funnel. We have a very nice framework that we can use to help you to perform the assessment of your strategic objectives and align them with the current status, help you to identify the use cases and then to prioritize. And last but not least, to help you identify and select the perfect proof of concept that you want to start before industrializing it. So please check out the our website. And now that let's say we have a roadmap, it's time for demo. Let's have a look on the first example. So yeah, thank you, Theo, for entertaining the audience. Just a second while I'll switch
Of
my
course.
my
Yeah.
tool.
So yeah, Dumi is preparing a very nice demo for you. And while you will see, we hope that these demos will open your eyes to what's possible, to how agents can help us these days. Um, I think both of them have certain flavors that you will like.
Yeah.
Yeah, this is the first one.
This is the first one, and we'll explain a little bit. It's very, very similar to the slide that we have previously, with a little bit of the agentic
Hmm.
AI example.
With the
In this
triage,
case,
right? And the
yeah.
mhm.
In this case, we have a customer that performed an order on an e-commerce website, and now it's not sure about it, and goes to a chat, and behind that chat, we have already an AI agent, a customer-facing analyst and manager. First of all, because it's the one that is responsible for sending the messages and interpreting the messages from the customer, and also the manager because he's the one that is delegating the work towards the specialized agents. In our case, we have an order query agent and an order cancellation agent that both connect using standard tools or APIs towards a e-commerce platform. Not limited to this API, it could be a web browser, it could be a command live, it could be a graphical user interface, and so on. And now let's start it, and
All
let's.
right.
Okay. So as you can see here, this is the chat. But before that, let's assume that we are the user and we already created an order. I will create a sample order for a customer. Use a standard address. Let's add a couple of products, and yeah, let's add this, like this. Let's
So you're
select.
basically creating an
Yeah,
order
I'm
now.
creating an order just
Hmm.
like a customer would have created on a, let's put a shipping method. Okay, and let's finalize it. And then you see we have this order ID. So now let's log in into the website.
And now you're the dissatisfied customer that wants to
Exactly.
do something
Exactly.
about his order or
Hey
her
there.
order.
I want to check the status of my order. And now what will happen, it will go to the delegating agent. That one will delegate towards the order query agent, but the order query agent will know that in order to query an order, they would need an order ID. So let's see what's happening. Yeah, so it's thinking. And sure,
Mm-hmm.
can you please provide me with the order ID so that I can check the status? And as you can see here, we already see the React pattern that Theo mentioned in the presentation. Customer-facing agent that does the thought. The customer wants to check the status of their order. I need to obtain specific details from the order query agent. And then the tool, which is in our case, the other agent, says that they need an order ID. Okay,
Mm-hmm.
so
So basically, agents are collaborating now with each
yes,
other, right? To
yes,
achieve the goal of
yes, exactly,
checking the status of the order.
exactly, exactly. So now
Okay.
the same will happen. The request will go towards the order query agent, but this time the order query agent is able to query the e-commerce platform for the order. And
Mm-hmm.
as you can see, all the order details are here.
Yeah.
So yeah, these were the order details here. Three items. We have the same number of items. The total price as well. 149.59,
Mm-hmm.
149.59. So it's exactly the same one. So now let's assume that I'm the customer. I ordered the wrong shipping method. I would have liked FedEx instead. So says, okay, if my shipping method is UPS, I want to cancel my order.
Mm-hmm.
So now what happens? It goes and either uses from the memory the status of the order, or it goes to the order query agent to query the orders, and then goes towards the order cancellation agent to cancel it. So as you can see here,
Mm-hmm.
yeah.
So this is where
So
agent specialization comes into play, right? Each agent is responsible for one thing and one thing only, right?
exactly, exactly. So at this moment, you see that before that the order had unfulfilled status, and now if I refresh, I would expect canceled. But this is just a very simple example.
This
Your
is just a
imagination
simplistic,
can go
yeah.
wild and imagine that this was done in hours. Imagine what you could do in days to remove repetitive tasks that take out of people's time. So there are
Mm-hmm.
many opportunities here. And now I will show you the next example. And this is a glimpse of the future. This is an experimental framework on top of AutoGen from Microsoft. This is a autonomous generalist multi-agent system for complex tasks. It should open our eyes to see what is possible in the future, especially when this will be combined with the classical RPA techniques. So basically, this one what does takes a task in the form of human language,
From a
plans
user, right?
performing the task, creates a progress ledger on top of that, and interacts with various specialized agents like web server, file server to manage files, compute terminal, or coder. But for the today's demo, we have an example with a web server where quite a complex task for many of us to buy a desktop PC, a gaming PC, and building from scratch with the gaming components PC. So let me start the other example as well.
This is for you, all you gamers out there,
Yeah.
myself included.
Okay.
So Aldumi is loading his example. So basically, what the system does is take a task from a user, and then just by human language, right? The user just says, "Hey, I want a gaming rig. Please help me out," right? And then the system compiles a plan it then creates this process ledger that Dumi showed us, and then it delegates actions to the various specialized agents. And these specialized agents come back then to the orchestrator agent and with progress, and then orchestrator agent checks to see if the progress was made, uh, continues the actions that the specialized agents need to do, and so on and so forth until it reaches its intended goal. Mind you that this can also come into play with human in the loop. Right now, this example doesn't have it, but uh, if needed, and if the task is so complex that it cannot be achieved without additional instructions from the user, we could actually enable human in the loop. And the orchestrator would go back to the user and say, hey, you didn't give me your credit card information, you didn't give me your shipping address, you didn't give me, I need more so that I can achieve that task, right?
Yeah, exactly.
All
So
right.
I think I'm ready. So this is the sample task that you want to give to such an autonomous agent.
Mm-hmm.
Navigate towards Amazon. Please identify on Amazon the components to build a gaming PC and add them one by one to the shopping cart. In the end, show me a list of the components from the cart together with their price. Let's see
Mm-hmm.
what's
So
happening.
that we can discuss with our wives and see if we have the budget for them.
Let's see. Okay. And you see, this is usually hidden, but for demo purpose, we allow it to demo to show on the browser the step that is performing. So as you can see, already started to go for Amazon, and now if you see here, if you see below, navigate to Amazon by typing the URL, and then yeah. I wanted to show you the ledger, that we updated ledger, and basically continuously says, is my request satisfied? Is my task finished? Am I in a loop? I mean, am I blocked or something like this? However, did I do any progress? What is the next speaker? And then decides instructions for the next
Mm-hmm.
question. So let's see what already it's starting to search for gaming CPU. So
Mm-hmm.
already the plan has been made.
And Dumi, you're not touching the keyboard now, right?
No, no, no,
It's
I'm not.
doing.
I'm not doing
Mm-hmm.
anything. So what you do in the console here, in this part, it's the agent working, and this browser is controlled entirely by the agent. Yeah.
Mm-hmm.
So
That's if this looks like RPA, right? Robotic process automation, which interacts basically with user interfaces. It is similar in that regard in this, let's say, more simplistic example. But what Dumi showed us earlier is that these agents can do so much more. They can interact with user interfaces or surf the web. They can code and run code. They can run commands in the computer terminal. They can interact with files on your file system. So they can do a lot more. And the difference between these systems and the RPA ones need a predefined workflow, right? They need the things to be in that place and the things to go in that sequence all the time. If there's one thing which is out of place, it breaks the workflow. It can no longer function. Here instead, the multi-agent systems reason about and check to see, do I have errors? Is Amazon not working? Maybe I can try some other. These are systems that can think for themselves, and they can take decisions, make decisions to achieve their goal and work in a basically not a predefined static workflow with 7 steps, but a dynamic workflow which can have X number of steps. Am I correct in stating this to
yes,
me?
yes, yes. So this is the main the autonomy is the main difference between classical RPA and this
Mm-hmm.
agentic, and also the fact that it can reason and take decision and is able to autonomously communicate with the tools at hand, and also recover from failures. And by the way, while as you can see, they already so they already did the motherboard, memory, gaming GPU, and so on. One last thing, I want to show you how the websites are being interpreted using AI, and fields and places where it needs to go and do an action just like a human would do, look like. So yeah, while we are waiting for this to finish, I think that we can go towards the question and answers session. I remind you that you will receive a link just now from our colleagues. Please leave your feedback, and three lucky winners will be selected for a free AI agent implementation using standard tools, something very similar to what we have shown you, especially from the on the first example, something that yeah, could be also production ready. So yeah, we are looking forward to hearing your questions. Yeah. So we have one question. If did you have any project related to customer support, something like assign the case to a specific team, define your use case priority based on predefined criteria, search for similar cases you had in the past, and bring the knowledge articles available to different sources. This is a very good example that works very well with the first example that we did. All the components that we have used there would be possible here. So we would have a manager, we would have specialized agents that would do RAG on top of the knowledge base. We would have specialized agents, or not even specialized agents. In this case, I think we would have some agent that would do based on real predefined rules, programmed or with the basic rules that routing would be done. So that is feasible, and taken one by one. We have implemented each of these steps, but not in this scenario, but totally feasible. And yeah, using an agentic framework like Crew AI or AutoGen, and with RAG capabilities on top for the knowledge management, I see this possible and production grade during nowadays. I hope I responded to your question, Alexandru. Yes, thank you. Other questions?
We have one more. We have one. So this means I can fully automate my carimages.com project. Agent one searches the internet for used car dealers. Agent two, outbound call. Outbound call agent Pearl to do the sales process. Agent three manages payments and does the onboarding. Agent four, chatbot as help desk.
Do you want to respond to this?
Yeah, each as you've nicely put it, Jürgen, you've nicely put it that you need to define each agent and its job description, as we mentioned earlier, right? You think about it as a person that would do that job, what it needs to do, right? One is could be responsible for searching the internet, right? And you need to provide it with the necessary tools to do that. One agent can do the outbound calls or sending messages or text or whatever. One can manage payments, of course, as Dumi has shown us, right? They can interact with
Yes.
orders, cancel orders and whatnot. They can manage payments, of course. And
Yeah.
one can act as a help desk. And in Dumi's first example, the help desk can then have its triage agent, and then it can delegate to more specialized agents depending on the problem that the agent faces when doing the help desk. So yeah, the question in essence is what is the one-time cost to implement something like this, and how much is the ongoing cost to keep it up and running? That's a very good question, and very difficult to answer at this point in time when things are so competitive and there's so many large language models and agentic systems and orchestrators coming to the scene now. But the good news is that there are many which are open source. I don't know if Crew AI is open source. AutoGen is
Yes,
open
it is.
source.
AutoGen is
Okay,
open source as well. Yes.
as well. So you could actually run it. It depends on what you want to run and how you want to build it. Well, you could build it as using low code solutions, and now frameworks have appeared and services out there that allow you to build agents in a low code environment just by stringing together and creating that job descriptions that I mentioned and stringing them together into a multi-agent system using low code, or you could just go full code if you
Mhm.
really need specialization and you
Yeah.
really need the level of control that full code provides.
Yeah.
Uh,
Yes.
Depending on that, the cost can go, up or
Yeah.
down.
Yeah, and also what I see here with the with in terms of cost management, so the outbound call agent, it's possible with the nowadays technology. So you can use services like Azure Speech to Text and Text to Speech, yeah, to interact with your agents. But you, depending on the volume of the calls, depending on the volume of the calls and the length of the calls, this could be costly or not. You have to pay attention of the on the costs
Yeah,
with
exactly.
this one. Yeah,
And
nevertheless, it is feasible, and also it could be probably, it depends on agent two. There could be some latency with the nowadays technology in the discussion with the
mhm.
customer. If there is no discussion, no not a lot of back and forth discussion with the customer, then I would see it. Very very feasible. Otherwise,
Uh,
yeah, the
and
latency.
I
Yeah.
want to point out one more thing. The costs can be estimated, the cost of running it,
Yes.
um, as long as we know the number of users that you expect, how many sessions you would expect, right? How many cars you usually sell, and knowing those numbers, uh, we could do a simulation and see the running costs of doing that, but also cost of building it.
Yeah. So we also have another question. Why use computer vision to process the page results? I think that in that example, it's DOM. It's not. I think everywhere where there's HTML, and I'm pretty sure in that example it's DOM, so it's not computer vision. But there will be not web pages, other situation where computer vision is useful.
Okay.
Okay. We have another one. We have another question. How I can transfer the human know-how for manual processes from the team to the agents? Like in RPI, you hardcore the flow, but how can you teach the agent about the current practices? That is a that is
By observing,
yes,
learning and doing.
learning and
So
doing, yes, and
exactly.
with
So
very good instructions, and allow the large language model to reason around that.
mhm.
Another
But yeah,
question is if we have an example from the construction industry, especially with internal data documentation for suppliers. Yes, actually we have. We have something like that in the construction industry. It's not collecting data, but it is an example where assignments to students are being sent, and these assignments are afterwards evaluated based on a set of bibliography. And what we do with these agents, we first define the assignments in natural language with the learning objectives and the criteria for evaluation. Then we take the bibliography, we chunk it into sections, and then using large language model, we associate section with the criteria, saying, hey, this section is relevant for this criteria, this section is relevant for this criteria, and afterwards, with another agent, we do the same with students' papers and we evaluate those students' papers. So that would be very similar. And I think now with services like Azure Document Services, collected data from suppliers and automatically translate the data into the system, yeah, that's totally feasible today. So yeah, that's possible. And we have experience with, let's
Mm-hmm.
say,
Okay.
documents from the construction industry.
Yeah. We also have some questions in the Q&A section. So we have here one question: how do you estimate LLM costs for AI agents? And this is something we might have already touched on, but just to summarize it, it's basically we need to estimate the number of users and sessions that we have interacting with the agent. We need to investigate to observe the average cost for one session by observing the average input token length, output token length, right? Because, for instance, take in consideration the React agent that we showed earlier, right? It's
Yeah.
doing its thought process, right? It's
Yeah.
running in a loop. But what is the average number of loop iterations that it goes through until it reaches an end, right? So we need to observe by running a few examples, and in the use case, in the particular use case that you're thinking of about. Once we observe that and we have the average input token length, output token length, and the chosen LLM, we can, of course, extrapolate and calculate uh, the cost of running it.
But but that is not all. This is the very first time. This is an estimate.
Yeah.
Afterwards, when we start working on the very first, after we know the prompts, we have the flow. What we are doing, we are measuring token by token and see real costs. And afterwards, we can really extrapolate depending on expected volume. So it is very important that you have observability right from the beginning of the project while you are doing development to understand the number of tokens that you consume and to adapt on the go so that you
Mm-hmm.
don't have surprises in the end when you developed a very nice agent and then you realize it is very successful, but the success has a huge cost because you have to pay for the inference costs. So you have to estimate initially, but also continuously monitor the token consumption even during development. Yeah, that's
Mm-hmm.
another recommendation. Yeah. And I
Okay.
see that Jurgen told us that he already tested the Ample outbound call service. So that is great. If that one has solved this problem and you have a nice API to integrate with that. So
Mm-hmm.
the answer for Jurgen that that agent is totally feasible with the tools nowadays, with frameworks
Mm-hmm.
like Crew AI and or AutoGen or yeah. For
Yep.
us, these are the most popular ones.
And there are more questions in the Q&A. Let's try to get as many as we can. There's one question: how do we go about programming these agents? What do you use? What is your thought process? Would you like to take this one, Dumi, since you worked on the examples?
Well, let's go back to the demo. I mean, let's go back to the demo. Uh, one moment. Not this one. Let's go to this one because uh, we have this. This was with Crew AI, yeah.
Hmm. Yeah.
So this
But
is
the thought
think.
process, I just want to emphasize one, the thought process comes from, again, going back to the drawing board and the job descriptions that I mentioned, right?
Exactly,
You need to
exactly.
think what are the roles of the various agents, right?
And what are the
And what,
tasks?
hmm
And what are
yeah.
the tasks? And you should think of them just like a manager would do. Yeah. Think of roles, think of job description, think of goals, and think of tasks. just like we have here. So this is the most, I would say, the most the customer face. So this is the role here, the customer facing analyst manager. This is the goal: interact with customer, understand their needs, and coordinate with specialized agents. And this is the backstory. You are the primary point of contact and manager of customer support at Mindit.io e-commerce platform. Your role is to understand customer query, delegate the task to specialized agents, coordinate their efforts, and provide seamless support experience. You can
Mm-hmm.
handle queries related to order information and cancellation. And also, you see here, this one has delegation, allows delegation. The other one, which are a little bit more specialized, you see they don't do a delegation, and but otherwise they are in a similar way configured. And also here you also tell, hey, this is the tool that you use in order to do your job. Whereas you see this one, the manager does not have. Yeah.
Mm-hmm.
So I
That's
hope
nice.
I answered
So
this question, right, Theo?
I think so, yeah. So you do it in a declarative way first. You define the agents and then how they interact with one another, right?
Oh,
Their interactions,
yeah, and I missed an important part, the task.
the tasks.
So,
Yeah.
yeah, the task. This is the task where you provide the conversion history that comes from the front end, and then you tell what is the task. And by the way, this is the task of the manager, because the
Yeah.
manager gives tasks to others. Yeah,
Yeah.
and that's
Yeah.
what the
Yeah.
manager does. Yeah.
All right. All right.
All right.
And there's another question here. How would the normal company get into building this themselves? Is that possible? What type of agents would you recommend for a telemarketing company? Um, maybe you can think of an answer for the second part of the question. The first part of the question, how would the normal company get into building this themselves? Well, course, you need to hire specialized or raise within your company specialized skills, people with the skills to do it. Because again, you still need people to create these specialized agents, either by using the pure code, which you see here at Doom, which Doomy has used, or by using the low code options. You still need to know about orchestration patterns, the AI agent patterns, like the React pattern that I showed. You still need the skill sets. So you either hire or train people within the company to do it, or you hire an external company to do it for you, right? In which company which has business analysts which can interact with you, find out what your pain points are, and work with you together to automate your business processes
Yeah.
as much as possible, right? And
Thank you.
for instance, for a telemarketing company, Dumi, what do you think?
For a telemarketing company, I would use tools like AutoGen and Crew AI at this moment, and I would make heavily use of integration with the knowledge bases. Yeah,
Mm-hmm.
and also very important and measure of success for all the projects will be the guardrails that you put. So you have to thoroughly test it, put the proper guardrails in place, and
Mm-hmm.
as much as possible use APIs, so
Yeah,
that, because APIs are the ones where you can programmatically put
yeah.
the the most
And one
the best guardrails. I think in terms of speech to text, text to speech could be
exactly
could be a challenge in terms of costs at this moment. But
could be a
there are
cost, but
specialized solution like someone from the audience told earlier about Amperl. Yeah.
exactly. There, so the LLM, which sits on the center, which is the building block that I showed you earlier in the presentation, does not need to be just a text-based LLM. It can be a specialized speech text or text to speech, right? It can be a multimodal model that can generate images or generate speech or interpret speech. So it can
Mhm.
do outbound calls. It can do a
Mhm.
conversation using audio, not only text.
Yeah.
So yeah,
And one
there are
last
agents.
question.
Mhm.
One last question. What is the coolest you guys have built so far?
That's hard
And
to pick. That's hard to say.
I would say Theo, the one with the AI travel agent.
Hmm.
because it's you don't see AI behind that, but you have a very cool graphical user interface, and yeah, but you know more about that project.
Yeah,
Yeah.
it's basically something that will come out soon. It's a system that works together with uh, travel agents. Again, the name agents that
Real
work.
travel agents.
Yeah, real travel, like people that work with the customers like me that want to travel, and they work with you to generate an itinerary. So you plan to travel to some a country or more countries or a region, and but it helps you generate an itinerary. Let's say you travel for 10 days, it generates an itinerary for each day. But it first builds a what we call a customer 360 profile. So it asks you questions about what you like to do, what you like to eat, how do you spend your time, and it learns from you and uses that learning to then generate a customized itinerary for you. So that person, that the travel agent, life is so much easier. He or she doesn't have to start Googling about, best place to eat sushi in Paris. The AI can do it for it, and it serves you that itinerary. So basically, as a customer, you would get not only the plane tickets, the booking, but also you would get, hey, here's a nice itinerary. Places we recommend you to visit and places we recommend you to go. So yeah, I think that's one of the coolest things. There are others, but we don't have time
Yeah.
to go through them.
Yes.
There's one more I would like to answer. Other examples of AI agents that interact with the outside world. I have a passion about smart home automation, for instance. But that's not the only example. Just bear with me here. You can have agents that run your smart home. You can have, for instance, they start automated vacuum cleaners at specific intervals or based on sensors in the house. They detect dust or humidity and start dehumidifiers, or based on cameras around your home, they can detect attempts to, jump the fence to break the home, and they can, sound the alarm. They can do pretty much a lot of things, turn on the light, turn off the light, but not on a schedule, but smartly, right? When it sees that the lights are dim, when it sees that there's darkness outside, when it sees that I do irrigation to water my plants around the house. So I can use them, for instance, uh, to check if it's raining or not, if what's the humidity, but only water the plants when it's not humid, when it's not raining. So all sorts of things that you can interact with the outside world with IoT devices, and you can make agents dynamically decide what happens next.
So thank you very much. This was the last question. That was very engaged audience. Thank you for your questions, and thank you for your support. And yeah, please don't forget to complete the feedback. And as we said, we will select three lucky winners from the audience for an AI agent POC implementation.